Hey folks, how's it going? It's Mr. Murray here, and this is a video for Course 1 Honors for Thursday, May 28th, 2020. And as we're getting ready to close out the 10th week of the school closure and have our wonderful hangout tomorrow, I'm here with you today giving you two problems that are exponential equations for you to solve. So here, as we've been talking about, these are equations where the variable is in the exponent. And so remember, our goal is to get the right-hand side to be a power of 3, or whatever number is the base, right? Get bases alone, right? To rewrite that, to cancel the bases and bring the exponents down, and then to get the letter, whatever it is, alone, whether it be x, q, r, whatever. So if you haven't seen it yet, I do encourage you to check out the materials for the past couple days on this. But when you're ready, what I need you to do, go ahead, pause the video, try to solve these two equations, and then when you're ready, unpause, and you can see what I got. All right, so remember, first, basically it breaks down like this. Basically, we want bases alone, right? So you want to get the thing with the x or whatever in the exponent alone. So this is the bases alone. This is the base you want to get alone, and that's the base you want to get alone there. All right. Step 2, rewrite other side as a power of the base on the left. And that's because what you want to do is 3, you're going to use the one-to-one property to bring the exponents down, and then 4, finish solving. Okay, so here's how it works. Let's see it in action. First one, right, and I'm just going to put a little bit of space in here so I got room to work. So step 1, we want to get the base alone. So I'm going to subtract 9 here to get the base alone. So 3 to the power of q minus 2 is equal to 27. Now the bases are alone. Now I'm going to rewrite the right-hand side as a power of the base on the left. So that is, I'm going to rewrite the right-hand side as a power of 3. So it's equal to 3 to the power of 3. Remember, we don't have the tools to be able to solve these problems unless we can use the one-to-one rule, which is we need to make the bases the same. Now, because these are equal to each other, the expressions, and the bases are the same, the exponents must be equal to one another. So therefore, q minus 2 is equal to 3, and solving for q, you get q is equal to 5. If you plug back in, 5 minus 2 is 3. 3 cubed is 27. 27 plus 9 is 36. All right, second one's going to be similar. So here first we're going to start by subtracting 8. So I get 2 times 5 to the power of r plus 2 is equal to 1,250. Now what I'm going to do is divide by 2. So I get 5 to the r plus 2 equals 625. Now what I'm going to do is I'm going to rewrite the right-hand side as a power of 5. So 625 is equal to 5 to the power of 4, right? Because power of 1, we get 5. The power of 2, we get 25. The power of 3, we get 125. The power of 4, we get, not 4, the power of 4, we get 625, okay? And now because 5 to the r plus 2 equals 5 to the 4th, right, the bases are the same, the expressions are equal, that means that the exponents must be equal. That is, r plus 2 must be 4, so r equals 2. Checking our work, 2 plus 2 is 4. 5 to the 4, as we just saw, is 625. 625 times 2 is 1250. And 1250 plus 8 is 1258. So hopefully you're able to get these both right. If so, congratulations. Otherwise, go back and make sure you understood where you might have gone wrong. Remember, the key here is the idea of quote-unquote bases alone. Don't worry about the fact that you got an exponent here. If this was tricky, pretend like you had the equation 2y plus 8 equals 1258. How would you get y alone, right? Well, you have to subtract 8 and divide by 2. It's the same exact process here, and that's exactly what we did, except that was to get the 5 to the r plus 2 alone. Okay, so a lot of overlap with stuff we've done before, but keep it up. Please make sure you take a look at our extra practice materials today. Best of luck. Don't forget to love math, and remember, you can do it. Until next time, have a wonderful day.